All right, I guess we'll get going. My name is Dmitri, and today I'm going to talk about my grandiose title of Transforming Enterprise Development with Clojure. So what I'm really going to claim is that Clojure enables us to move fast sustainably, meaning that we can develop solutions quickly, we can iterate over them, we can make changes as we go, but the code we produce is going to be maintainable, so we don't get overwhelmed by the things we build. And my claim is that Clojure strikes the right balance between these two goals of maintaining the code and building new solutions. And my experience is a big problem in an enterprise. So let me tell you about myself first a little bit, and we'll get into this a bit more. So who am I? I've been working with Clojure professionally for the past 5 years. I primarily work with web applications. And back when I started using Clojure, there really weren't a lot of libraries available. And a lot of best practices were still being discovered. So I ended up writing some supporting libraries I needed, like HTML templating and so on. Because they didn't exist, I ended up open sourcing those. And then I started building my own template for creating web applications with Clojure, because I found there was common patterns I had to do, and putting all the boilerplate together was tedious. And that's what ultimately grew into that Luminous framework I'm maintaining. And there's an idea in Clojure community that we prefer using libraries over frameworks. And the idea is there that when we put libraries together ourselves, we have more control over that. And Clojure is already expressive when there isn't a lot of boilerplate, so it's fairly easy to put things together, so you don't really need a heavy framework. And so Luminous is really a framework in the sense that it's a template with some documentation around it. But the value there is if you're new to Clojure and you're evaluating it, you don't know what the best libraries are. You don't know how to put them together. You don't know what's maintained. And you don't have comprehensive documentation in one place. So the putting libraries together approach only works if you already know the ecosystem. And Luminous aims to provide a path for new people to get into this ecosystem and start using it effectively. And that was also the motivation for writing the web development book I wrote, I think, in 2014, and then having a second edition recently because a lot of things changed since then. And finally, I work at a hospital, so I work in a healthcare environment. And it's really important for us that our applications work well because they affect patient care. Doctors use my applications to make clinical decisions, and my code has direct impact on patient care. So if my software works well, you'll have a shorter stay at our hospital with a better outcome. I think that's what everybody wants. So let me tell you a little bit more about my environment. Being a hospital, University Health Network is a research hospital, so we have a collaboration between major hospitals downtown Toronto and the University of Toronto. And so the data we collect from our applications is often used for research as well. So when we build multiple applications, we have to have this comprehensive data model that can be usable later for data warehousing, analysis, and so on. And what we end up doing is my department will work with clinicians, and we try to identify gaps in the workflows and opportunities for improvement of the clinical workflow. And many times when we work with the clinicians, we find that there is an off-the-shelf product that fills the gap. At that point, we engage a vendor, they build a product, gap is filled, everybody's happy. But many times we have scenarios that are unique to us, and there isn't any off-the-shelf product that solves that problem. And that's when my team gets engaged. So then we actually work with the users, we try to shadow them, see their workflow, try to understand what the problems that they're having, and how to solve it. And initially, the users will know they have a problem, but they don't know what the solution is, and neither do we. And that's where this need to prototype and experiment comes in, because we have to try different things, see what will work best. And we need tools that allow us to do that. And at the same time, whatever we produce, we have to maintain. And we have a fixed-size team. We are building more and more applications, so we don't want to be crushed by the weight of the code that we create. And these are kind of the goals that we're struggling with, again. So what didn't we like about the tools we used? We used to be a Java shop. My team worked with JE, JSE, We tried pretty much everything, WebSphere, WebLogic. And what we found is that Java made it difficult to do this rapid prototyping. There was a lot of boilerplate involved even in building simple projects. And a lot of this boilerplate comes from the fact that the language isn't terribly expressive. And when that happens, if your problem domain doesn't map to the constructs that the language provides, you end up having to create this boilerplate to translate your problem domain to what the language gives you. And at that point, you get all this incidental code that has nothing to do with your problem, but you still need to express yourself. And then when you try to read and modify this code, it's a lot more work than reading code that's direct and that states the problem clearly. So even when we prototyped, we ended up kind of taking shortcuts and not really following best practices, right? Just to spike something out to see if it works. And when we had that prototype, then when you decided on a final iteration, something that you think was usable, then you pretty much had to rebuild it following the best practices. And even when we did that, we found that those products were still difficult to maintain, right? Because you ended up with even more code, and it was even less flexible. So if the needs of the hospital changed, the workflows changed, it became difficult to update these projects. And there was a bit of a fear involved in changing things because Java is mutable by default. And a lot of things are passed around by references. And if you have a big project with a lot of references all over the place and you change something in one spot, you don't really know what else you might have affected. So you become very conservative about the changes you make to existing projects. And your projects tend to stagnate. And we didn't know if there was a better solution, but we know what we were doing wasn't good. We didn't like it. So that's where we started exploring our alternatives. And we were already on a JVM, so really our options were either Scala or Clojure. We initially tried Scala, but we found that it didn't work for our team. Like the language was complex, there was a lot of stuff you had to keep in your head to work with it. And even the code ended up being succinct. We found that we were just trading one type of complexity for another. With Java, you had a simple language, but it wasn't very expressive, so the complexity wasn't all the boilerplate you created. With Scala, you had a very succinct language that was very expressive, but you also had the language complexity. And what we found was when you were working with Scala, you'd always be working with parts of the language at any particular point in time. So whenever you work with one part, you really know how that works, but then you read some code that was written with different constructs from the language, and now you have to kind of like relearn them. It was a constant process, and we didn't really like it. So at that point, we tried Clojure, and we found that that clicked with us a lot better because the language was simple. So let me talk a little bit more about Clojure and what we like about Clojure and why we love it. So the first thing is it's interactive. When you work with Clojure, you're having a conversation with the language. And what I mean by that is you have a REPL. Any code you write, you can run immediately. And it's not a standalone toy like a REPL in a lot of languages. It runs within the scope of your application, within its context. So you have access to your databases, queues, any environment. So if I have a function that I want to pull some data from a database, I can write that function, run it, see that it's doing what I want, and run the next function, see what that does, and so on. In fact, I find working with Clojure is very akin to doing a mathematical proof. You might have a proof that spans many pages, but as you're working through the proof, you only care about the last step and the next step. And you're pretty much sure that the rest of it is correct because you went through a sequential process step by step, so you never have to consider entirety of it in your head. And Clojure is exactly like that. And it's also very expressive. So Clojure molds itself to your problem domain, so you don't have this translation problem, and your boilerplate goes away. But at the same time, it's still simple. Like, majority of Clojure is just calling functions. You have a large standard library of different functions that transform data in different ways, and you just put them together. And it's kind of like playing with a Lego. Everybody likes playing with Lego, right? You have a lot of different bricks. You can take those bricks, stick them together in some way, and you can produce this interesting, complex thing out of those simple pieces. But then when you need to build a different thing, you can take it apart, you can take the same pieces and make this different complex thing. And this is exactly the same thing when you work with Clojure. And it's very satisfying. And finally, it's immutable, right? And that, again, goes back to keeping things simple and you not having to keep a lot of context in your head. Because every time I make a change, I'm not modifying the data I was given. That stays the same, and the change happens in the context of my function. So when I come back to a project that I developed 6 months ago or a year ago, and I make a change somewhere, I know what the change will affect. I don't have this fear I had with Java where it's like, well, maybe I'm affecting a different part that might be having a reference. So you can make changes faster with more confidence. So again, to sum it up, what we really like is being able to do development quickly and produce maintainable solutions. So now I've kind of set it up a bit. Let's see it in action. We're going to work through a really simple Clojure app. And just for the sake of time, it's going to be extremely trivial. But what I want to illustrate is how you create a new project, how you work with a database, how you create a RESTful service, and how you implement a UI using Clojure script. And don't worry if you can't follow all the code. That's not really the goal. The focus is here just to see the workflow and kind of get an idea what it looks like to work on a Clojure project. So let me just switch to mirror mode. All right, so we'll hide that, and we'll hide that. And let's go to the terminal. Can everybody see that? Is that perfect? So first thing we'll do is create a new project. So Clojure uses Lane Engine mainly as a build tool. And is everybody familiar with Maven in Java? Some people? Okay, so basically what it does, it manages dependencies. It can manage build tasks, it can run tests for us. It's kind of like a one-stop shop for managing your project. And if you're working with Clojure and Clojure script, it's really nice because you have one build tool to manage both. You don't need stuff like Gulp, NPM, Grunt, like 5, 6 different tools just to build your UI. This will do all of that for you. And you can share libraries between Clojure and Clojure script. And again, it happens all in one place. You just add a dependency. Many libraries nowadays cross-compile to Clojure and Clojure script, so you can use one library on the front end and the back end and have the same semantics and same behavior between it. So if you're doing stuff like validation logic, you don't have to worry about, it's like, oh, you know, I made validation on a client, now I have to write it on the server, and now I have to use a different language, and it might be subtly different, and I might have some errors in the end. So let's just unpack that. So we're saying lean new. Luminous is the template we're going to use. Guestbook is the name of a project. And it's followed by some hints. So we want to use SQLite database. We'll add a Swagger UI to it. And we'll have Clojure script. And I'll run that. And we'll make a new, oh. Let's get rid of the old project I made and try this again. And there we are. So we have a new project. And we can run it. And this just starts up the main for the project in development mode. We later can package the project into a standalone Uber jar and run it that way. But when you run in development, if you get stuff like code reloading and any errors will get unpacked, so we can see them in the browser and so on. So there's a few advantages. So while that starts up, I'm going to go to IntelliJ and open this project there. And the nice part with Lane Engine as well, that all Clojure-aware editors know how to work with Lane Engine project structure. So you can use whatever editor you like, and there's many now. You can use Eclipse, IntelliJ, Emacs, Vim, Atom. So different people on the team can work with their own preferred environment, and you're not really locked in into using a single editor to work with a language. So what we'll do here is we'll go edit the configuration, and let's see if this started. And we can see when the app starts, it will start a REPL on port 7000. And I can connect my editor to this REPL. So I'll go here, and I'll say I want to make a remote connection. I'll call it REPL. It'll be on localhost, and it'll go on port 7000. And now I can run it. And so now we can play around with our application live. But before we do that, let's set up our database. So the idea behind our project is going to be it's a guest book. We'll have a table that has a guest and a message. And we'll be able to list messages and add a message. So let's create our table first. And the way the project is set up, there's a few folders in here. But one we care about is resources and source. So resources will contain all the static assets, such as HTML templates, migration files, SQL queries. So let's go to our migrations folder. And we see there's like a sample migration table set up for us. We'll blow it away because we're not going to work with the users table. So we'll have, create table. We'll call it guest book. Guest book will have guest, that's text, and message, that's also text. And now that we made this table, I'll go to another terminal and go to the guest book folder, and I'll do a lane run migrate. And migrations are built into the app. So we keep the migrations in the folder within the application. They will get packaged with the application into the jar. And once they run, it'll update the tables. So it makes it really easy to follow best practice, to keep your, not use an external tool to manage your database, but keep migrations right with your application. And if you build your application and put it in your staging or production server, you can run the migration straight from the app, and it can manage the updates. So here we go, we created our database. Then let's go to our SQL folder, and we have some queries here. And Luminous defaults to using the Hug SQL library, which basically applies HTML templating concept to working with SQL. We write our SQL using plain SQL, and any dynamic variables will be passed around as Clojure keywords. So functions that take parameters will accept a map. Each keyword will map to a variable we want to pass to our template. And this guarantees that there's sanitized and parameterized queries, so we avoid stuff like SQL injection by design. And then the name comment specifies the name of the function that's going to be generated. So again, we don't really care about the functions that we got, so let's make a new one. We'll call this function getMessages, and we'll provide hints. The first hint is a command, so we're saying it's a query. And the second hint is a result, which will be multiple rows. And then we'll say select star from messages, or from guestbook, sorry. And then let's make a second function. We'll call it add message. And the command is going to be an update. And exclamation mark is conventionally used in Clojure to say that's a distractive operation. And the result is going to be number of rows affected, so n. So we'll say insert into guestbook. We'll insert guest and message. And values are going to be guest and message. And those are the parameterized values. So now that I have that, I can actually go to a REPL. And actually, let me show you first where this is going to get hooked up. So we have a database core namespace, and it manages a connection here. And then it runs this bind connection function that will generate the queries from the SQL we've written and bind those functions to use this connection. So by default, they'll default to using your database connection that's available. So let's use the namespace in the REPL. db.core. And then I can start it. And now I can run get messages. And we'll see we have no messages, which shouldn't be surprising. So let's try add a message. We'll add message, we'll pass it. Guest will be Jane, and message could be hello. Okay, so we get a result of 1. We affected 1 row. So let's get messages again. We can see that we get a sequence of messages there. And so in Clojure, most SQL libraries represent table rows as maps, where each key maps to a column, and the value is the value of that column. And when we get a result set, it's basically a sequence of these maps. And we don't really need any additional ORM or DSL to work with a database, right? We just wrote our SQL, and magically becomes available in our application. So there is no real mismatch like you have in object-oriented languages, where you might want to have an ORM library to map it to some objects and create a domain model. None of that becomes necessary. So now that I have some database queries, I'm going to go to our service namespace and add some services. And I'm using this Composure API library. And what it does is it defines service operations. So for each service operation, we declare the return type and the parameters. And based on that, it will produce the Swagger UI. And let's go to it in the browser and take a look. So that's here. And if I reload the page, I see I have a Swagger UI thingy. And it has these two operations. And they're documented. And I can run them. So if I go here, let's say 10 here, I can run this operation. I can see the result. I can see the status, everything. And this is incredibly useful for maintaining code, because if I declare a bunch of services, I now have this page that gets automatically generated that I can go back to and see what the services do, how they behave. If I'm working with another person, I'm writing the server side and they're writing the client, I can write my services, test them, give the page to the other person, they can write their client against it. So it's very, very helpful. Kind of like SOAP, really, but usable. So let's change the API to work with everything. So we'll say it's a guestbook API, plus will be get message, or let's just call it messages since we already have. So just to unpack this a little bit, like we have HTTP method get, that's a URI, that's a request map, then we say return and query parameters, summary, and then we return the actual result. So hopefully nothing too crazy happening here. So a return is not going to be long. It's going to be a vector with a map where we have a guest, that's a string, and a message, that's also a string. We have no parameters to this query, so we can just get rid of that. Let's add a summary, get messages. And now I'll reference a database. So we'll say guestbook DB core as, DB. And now I'll run this, right? So this will reload the namespace live in my application. And now this namespace has a reference to the database namespace, and I can use it. So instead of doing plus XY, let's say DB get messages. And let's try run this again, right? So we see this works. And we can see OK simply wraps it in the response of status 200. So the library basically provides a whole bunch of function names that map to HTTP status codes. So if I want to do a 500, I'd say internal server error and so on. Right? So now that we have this operation, let's update this one as well. So we'll say add or post message maybe. And return is going to be a long, because it's going to tell us number of rows affected, and the parameters will be guest of type string and message also of type string. So we'll say add new message. And here we'll swap this out with db add message with guest being the guest and message being the message. Okay, so let's test that we didn't break stuff. I'll load this up again. Oh, sorry. Oh dears. So I can't spell. So you can see how we get a nice error page right in the browser. I don't have to go to console, check the logs. I get immediate feedback that I did something horrible. And let's fix that and try again. And there we are. So let's test our messages. I'll try it. And there's our response. Everything's OK. We have the message we inserted during the REPL session earlier. Let's try post a new message to make sure our API works. Let's say we have John, and John says, hi. Try it out. Again, status 200. Let's confirm we have John's message. And there we go, right? And that's the server side. So let's just recap briefly. The only code we had to write, that was Clojure code, is in this file, and it's like 10 lines of code. This code maps directly to our database queries, which were written in plain SQL. So if you're working in an enterprise environment, you'll often have a DBA. They're probably going to work with SQL queries and optimize them and so on. So you can say, hi, DBA guy, can you please write me an optimized query for this operation database? And your DBA guy will write whatever SQL they have, Oracle, PSQL, or Postgres, and whatever, give you the query, you stick it in a file, give it a name, and now you can map it to a service. So all the code we've written is very direct to what we're trying to do, right? There is nothing incidental about it. And at the same time, it's very simple code. There is really, hopefully, even if you're not familiar with Clojure, it doesn't seem too crazy to you. Or if it does, let me know after the talk. So now let's take a look at working with a client. So if you go to our page and reload it, it instructs us that we have to run this lean fig wheel thingy to compile Clojure script. So let's do it. And this is a Clojure script compiler. It will compile our Clojure script code to JavaScript and run it in the browser. But in addition to that, when we run it in development mode, it will open a WebSocket to the browser. And whenever it detects changes in one of the namespaces, in Clojure script namespaces, it will hot load those functions to the browser without having to reload the page. And what it really allows us to do, that's really fantastic, is we can start building our UI, we can start building state in our UI, like we can add some pages, we can navigate somewhere, we can put application in specific context, and then we can work within that context. We can get some data, see how it looks, see how we need to change it, and we get this live feedback without having to reload and rebuild the context every time. So now that it's started, let's go to our page, and it should look a little different, hopefully. There we are. And let's look at the code that's responsible for this. So here's our core namespace. I'm going to close the REPL stuff because we won't need it anymore. And hopefully this is somewhat readable to you. So we have an init function that starts up the app. It runs the mount components function that will find the element with the ID app and mount the home page in that element. And notice that HTML is represented using plain Clojure vectors, right? And because both can be HTML and Clojure code can be expressed as S expressions, they map one-to-one directly. So we're using Clojure syntax to write HTML, and it's actually much cleaner, in my opinion, than regular HTML. And we can manipulate it like regular data, and it's just part of our code. So you don't have this problem like with Facebook React, where they invented JSX, because JavaScript syntax makes it painful to write HTML. So they have this like embedded DSL in their JavaScript that kind of looks like HTML, but it has its own rules and needs to be compiled separately. None of this is necessary when you work with Clojure script. Although if you did want to, there are libraries available that let you use kind of like HTML templates and snippets. So if you prefer that, it is an option, but I've never found it to be useful. So let's unpack this, right? So HTML tag is represented by vector. First item in the vectors has to be a keyword, and that represents the tag, and can be followed by basically CSS-style classes, right? So dot container means it's a container class. We can give it an ID. So I know like app or my app or something, since we already have an app. So it represents an HTML as very simple, right? And then if you look at this in a browser, if I do an inspect, just to convince you guys, we can see that there is our code, right? So we have a div my app, we have Jumbotron, and we have all this stuff. And that's the most basic reagent component. It's just a function that returns a tree structure. Now, components can be nested into each other. So for example, if I wanted to extract the Jumbotron, I could say defn Jumbo. I could take the stuff out of here and put it in Jumbo and return it in here. And it still looks the same. And you can see this hot reloading thing you show up, so it notifies you that code's been reloaded. If I make a typo, let's say Jumbo, then I'll get a warning in the browser again, right? That, hey, you have a typo here. So again, very quick feedback. And so far we have those basic components that really don't do much. They just return HTML, but let's add some state to our application. So let's get our messages from a server. And we'll store them in an atom. So we'll say, it's called messages, and it's going to be a reagent atom, and it's going to be an empty vector. And what an atom is, basically, it's a container for mutable data, and has separate semantics. Remember how I mentioned that things are immutable by default? So anything that's mutable will have its own semantics in Clojure, and you can easily tell if you're working with mutable data or immutable data. Now in Clojure, an atom is also guaranteed to have atomic operations. So say it's a sequence, and you update it, you're never going to see a partial sequence. In JavaScript, that's not much of an issue because it's single-threaded. But you retain the same semantics, and the reagent atom has an additional property, and that is any function that references this atom and looks at its value will get a listener. So whenever the state of the atom changes, any UI components that observe that state will be repainted by reagent. And this is really handy because now we don't have to worry about manually synchronized pieces of our UI. We just update our data, and whatever the state of the data is, the UI will reflect automatically. So let's get rid of our jumbo, and let's add a function called message list. And it will take messages as a parameter. It will create a UL tag. And let's say for each message in messages, we'll create an li, and we'll just str the message. Right? So let's update this a bit, say message list. We'll pass it the state of the messages. So know that we usually, with reagent, we want to create components that take data, not atoms, because then it becomes reusable. If I had the message list access the global state directly, say in here, then it's not, I can't really use it for other data. This way it's a widget. I just pass it the data wherever it comes from, and I can have multiple message lists that each observe different piece of data. And notice that I'm putting a message list in square brackets. I'm putting it into a vector. I'm not calling it like a function. Because I'm just declaring the UI layout. I'm not actually calling these functions. Reagent will then call the functions as necessary whenever the state of data changes. So each function, the message list, might get called many times during life cycle of the application, but I just declare that I want this element to be in this part of my UI. And of course, now we're going to end up with an empty page because we have no messages. So let's maybe make it a little prettier, and I'll just move it out so you can see what happens, right? So I can say H2 or H3, guestbook, and shows up, right? We can maybe put an HR here. So you can see how we can play with UI live. So let's load some messages. Let's say get API messages, and then we'll have a callback handler. And the handler will simply, it's an anonymous function that will reset the messages atom to whatever was returned by the server. And when I do that, I should get something, but I have a wrong URL, that's fine. So let's go look at our handy API, and I called it message, that's fine. So let's say API message, and if I go back, there's my messages, right? And I can see their maps. And maybe we want to fix the API, right? So let's go to our services, and that's where I screwed up. So I'll just change this to messages. I'll change this to messages. And it still works, right? So now I get this warning here from React saying that I have multiple items in here. And because I'm creating this list dynamically, React wants to address each element individually. If I don't provide some unique tag to it, it basically gets more expensive, so it has to iterate each message to see if it changed. So let's factor this out. Let's create a new element, message item. And we know we're getting a map. We can see it here. So I'll just extract the keys and say guest message. And this will return an li. This guest, let's say, make it prettier, says message. And we can replace this with message item and pass it the message. So it looks a little better. So let's get rid of our warnings. So we'll say map indexed vector to messages. And this will provide an index, a unique index to each message. So we'll do IDX message, and we can provide some metadata saying that the key is going to be the index. And that makes our warnings go away. Great. So let's just recap this, right? So we created a homepage component. Homepage contains a message list component. Message list component observes the messages atom we created, which is the global state. And it paints the messages, right? And we have all these helper functions for that. And then we get the messages in here, and when they're populated, the appropriate components get repainted. Hopefully everybody with me so far? Not too crazy? All right, so now let's add a form that will save a message to a server. So let's make a new function called message form. And this will need a local state. because we want to collect guest and message. It's a local concern for that component. The rest of our application doesn't really care about it. So let's create a local atom, and we'll call it a form, and we'll say it's reagent atom, and it's an empty form. But now we'll have a problem. If I put any component, like if I put a component that collects data inside it, whenever the state, if I change the state of this atom, then it will cause the message form to repaint, at which point the let is going to be called again, and the state is going to get blown away. Not what we want. So instead, we can return a function. And this works basically like a constructor in object-oriented language. We create some state called the form. We return a function that operates within the scope of that state. And this state gets preserved. So whenever this component gets repainted later on during life cycle of the application, the inner function gets called instead of the outer one. So let's put some stuff in here. So we'll say we'll have a div, and it's going to be a form group, and we'll have a label. Let's call it guest. And we'll have an input. That's a form control. And we'll have type text. The value is going to be the guest key at whatever is currently in a form. Meanwhile, on change is going to be basically the JavaScript on change event, and we'll have an anonymous function to handle it. And what we'll do is we'll swap the current state of the form, and we'll associate, I know it's hard to read, the guest key with whatever was in the event. So that's just the anonymous parameter for event. It has a property called target, and that has a property called value. So this is JavaScript interrupt right here, right? So in JavaScript, we have properties and functions, and we can't really tell because they're just maps. So Clojure script uses this additional syntax with a dash to indicate that we're accessing the property on a JavaScript object. Okay, so let's see what happens. We'll take this message form, and we'll stick it on our home page. Let's put it here. And there we go, right? And we can type in it. That's not very exciting. But let's say I create another component here, sorry. And let's say it's going to be a p tag. And we'll show the current state of the form. And now, if I type here, I can see that I'm populating the guest key in the form, right? And the interesting part is these two components don't know anything about each other, right? We have an input field that populates some data. We have the p tag that views the data. They know nothing about one another. They just look in the same data element. And this works across bigger applications as well, right? Like in a real-life application, we might have different pages in the UI, different parts of the application that represent data differently. They don't really need to know about each other. We don't have to coordinate them manually. The atom does it for us. So, okay, so now that we've done that, we want to create a message. And you notice we have some boilerplate here, right? So let's extract it into a separate component. Let's make another one called input. This will create this thing, and we'll give it a tag, ID, and the form. So then this will be, let's say, the name of the ID. This will be the tag. And instead of the guest, it will be generic ID that we pass in. Right? So now I can replace all that with an input. That's a form control that manipulates the guest key on the form. I can add another one. I can say it's going to be text area. So it's going to be a message. And this is going to be text area. And there we go, right? So we have Bob, test. So now we have two components. We've factored out all this ugly stuff into one place, and now we can reuse it anywhere we want. And all that's left to do is to actually submit the message back to the server. So let's add a function for that. And it will take the form as a parameter. It'll do a post to API message, I believe. And the params are going to be whatever the current state of the form is. And the handler will do two things. It will swap the messages, and that's a global atom we declared, and it will conjoin whatever we had in the forum parameters, and then it will reset the forum to an empty map so we can enter a new message. And let's add a button that will use this component. Button, primary, great. On click, we'll add message, and we'll pass it the forum. And let's say it's add message. Whoa. Okay. And there we are. So let's see, and let's get rid of that p tag since we're pretty sure we're collecting the data. Okay. So let's say Bob, howdy. Add the message. Oh, we got a 404 because I forgot what my API is. But let's copy this from here. I really like to put triple S's apparently in things. Oh. So let's try this again. Bob, howdy. And Bob says howdy, but let's convince us that the server sees the same thing. Oh, it does not. Oh, sorry, we got a 404 here. So hopefully, right, because I renamed the messages to message, or sorry, message to messages. And there we go, right? So we have the data round trip all the way to the server. Both the client and server know about it. The handler function will only be called for a 200 response, so for success. If you want to handle errors, we'd use an error handler. And in fact, we can add one. Let's say JS alert was whatever we get back. So let's say I mislabel a parameter in my forum. Where are we? Say we add an extra E here. The server will reject the message. And we'll get an alert, and we can see that we got a 400, and it tells us what we screwed up, right? So that's pretty much it. Let's go back to our message. So one last thing let's do, let's move get messages into our init function, just to keep things clean. And now that I've done all this, now I have a working application, as trivial as it may be. So let's stop this stuff. And we can do lean uberjar and package it for production. And it's that simple. And this will minify Clojure script to optimize JavaScript for production. It will compile our classes. It'll do everything it needs to do. And the other thing I'll note while it compiles, that during development, we were using environment specified in this profile CLJ file. And this is a file you don't check in. So when you have multiple developers work on a project, you have your project CLJ that has like common project configuration you check into your repository. But then each developer can have their own profiles file. And they can point it to their local databases for testing, development, and so on. And when I run in development, anything from here gets injected into the environment in my app. But when I build it for production, that's not going to be available. So then I have to pass any environment variables from the actual for shell variables or Java variables. And again, this kind of encourages this robust model where you don't bake stuff into your code. You always get things from the environment. And then when you have a deployable artifact, you can just dump it on the server, and whatever the server configuration is going to be inherited by it, right? So, and same thing as with migrations, where we package them with the app. We always have a history of whatever database changes happen. The app knows about them and manages them. So there we build the app, and now I'm passing the database URL as an environment variable, and hopefully it will work. And should also start a little faster because now it's not loading all the stuff for live reloading. So if you reload, there we go. And it's still using the same database, obviously. So we can say, okay, hi again. And our app still works, right? And this is it. This is an app. So we went from nothing. We had absolutely nothing set up. We created a completely new project. We created a database, right? We created the queries to run the database. We created a service API that has built-in documentation page for it. And we created a client. We packaged it all up. And now we have an app that we can put in production. So obviously, a real-world app is going to be a little more complex. But the complexity isn't going to come from Clojure, right? The complexity is going to be inherent complexity in your problem domain. The Clojure stuff is going to be very thin layer between that and your problem. And that's kind of what I was hoping to convey with this. So let's go back to the rest of the presentation. And basically just to go over, right, what we accomplished. We were very iterative and everything was interactive. Every time we wrote any code, we were able to run it and see what it did immediately. So we had a lot of confidence in what the app was doing. We caught errors very quickly, right? Because as soon as I made a mistake, the app would complain about it, I would fix it, I would move on. So I never get in a state working with Clojure where I write a whole bunch of code and then hope it compiles. This just never happens, right? Like every time I write every single function, I know it works. And when I go to write a new function, I know the code I already written works. And that's really important. We saw how easy it is to refactor code, especially in the client. Because your code is just a tree, you can select any node on that tree, pull it out in a new function, and because your data is immutable, you can just pass whatever the parameters was getting in that context as the parameters of the function, that's it. And that's how most refactoring in Clojure works. You often work through a problem, kind of try to figure out what you want to do, you might write some ugly code, but then once you know what it's doing, you'll just pull it apart and write the simple functions. And you do it on the fly, and you don't need to write stuff like unit tests just to make sure it works, because you can set up some data, some context right in your editor, play within that context, and once your code is doing what you want, once you have your functions finalized, then you can write some tests. And you can often take the code from your REPL session and just put them directly into your tests. But your development cycle is much faster than TDD. And finally, the UI was written in plain Clojure. We didn't need any additional DSLs, no special compilation tools. Everything was just Clojure. And another thing to point, like we use Clojure script. I think there's a big value in that because we use the same language on the front end and the back end. We use same data structures. We don't have to translate that. We can share code between them. But if you choose to, you can use a very thin Clojure layer, right? Because you could use HTML and JavaScript on the front end. You can use SQL on the back, so your Clojure becomes just a service layer. Or alternatively, there are libraries for Clojure that you express SQL using Clojure data structures, similarly to what we saw with HTML. So then your app could be entirely written in Clojure, like all the way from database queries to the UI. And you have the choice, right? Like it's really up to you, and it's very flexible about that. So kind of to finish it up, my statement is Clojure lets us move fast sustainably. We can develop things really quickly. The code we produce is going to be of high quality and easy to maintain. And that's been my experience. So now some questions. Thanks, guys.
I came in kind of late, so I may have missed it, but what's the testing strategy for all this?
Okay, yeah, no, I skipped the test because I wasn't sure if I'd have time for that. But basically, the app comes with test harness built in for Clojure and ClojureScript. We can look at the database test here, for example. And this test is just designed for the original user's database. But we could trivially change that, right? Like we could say, I know, get messages. And this happens in transactions. So when the tests run, they do a transaction and gets rolled back. The tests also run in the profiles. You can see we have a separate test environment. So they can use a separate database from your dev database. And that's what it defaults to doing, in fact. So here I could just say there is no parameters. And this should, well, actually, let's run it again. Why not? Oh, yeah. I'll just restart this. Sorry. Oh, yes, thanks. I really can't type. That's the main thing you guys learned from this demo. I can't type, especially when people are watching me. So, but basically, once we have this, let's get rid of the other test. There is a nice util called test refresh. And when you run that, it will watch for changes in namespaces, and you run your tests automatically in the background. And if you're on a Mac, it can actually hook into Growl So every time your test failed, you can just like ping and say, bloop, your test failed. So let's see. We started up. Actually, I didn't have to start it up, but test. I'll run this in the background as well. So let's connect to REPL again. And I'll just load this stuff. So let's see what we get from the messages. Well, actually, once this runs, I'll just do it here. Test users. Oh, okay. Use this. And here we go, we have a mismatch. So we probably want to go with this. And let's say we're expecting that. So if I run this, oh, still something horrible. Can anybody spot my typo? Oh, sorry, I'm just putting in the wrong spot. So this should not be equal to 1, but it should be equal to this. Oh, God. So let's run the test again. Oh, and I'll reload it. So there we go. And we can see in the terminal the test passed, right? So if I change something here, let's say we expect this, we can see that we have a mistake. If I take it back, we can see that it's fine. So that's usually a good testing strategy for that, right? You just run it in the background, it runs the tests, and it's very configurable, so you can have it run the whole test suite or a specific namespace or whatever you like. All right. All right.
Else is going to go. I'll ask questions all day long. So you showed the front-end Clojure script stuff off. How brain damaging is it for front-end developers to pick up Clojure script? I know some of my guys are really into it, but out in the real world, I don't know how it works.
So my experience is I have co-op students. So every 4 months I get a new co-op. They're straight from university. They've never seen Clojure before. Most of them have practically no experience with functional programming. They get productive within a couple of weeks. And I had students who built entire apps on their own in Clojure script without very little intervention, like once they get going. Obviously, you kind of want to supervise your initially. It helps with somebody who knows what they're doing, right? And they kind of inform the rest of the team. But it's not rocket science. And I think it's a lot easier to work with overall because the language is simpler and has better semantics. So there's less gotchas and trouble to get into.
How do you deal with a situation if you're working with a design firm that's providing a lot of HTML, CSS? How do you take that and translate it into something like this?
Right, so CSS actually stays, like even in our case, as just plain CSS. We have it in here, so that's fine. But as I mentioned, there are libraries called, there's one library I think it's called Q that works on top of reagent. And it lets you use HTML templates from the server. So you can put them in your public assets, and it will load the template and translate it to the Clojure script structure. So then that way you can end up with something like with Angular, right, where you create little snippets for each component HTML. The design firm can work with that. They give you the HTML, and your functions run. Or alternatively, you can try to teach designers to understand the Clojure script semantics. Yeah. So I think that's why this exists. All right. So it sounds like you guys are all were really bored by the presentation, or just knocked it out of the park. 50-50 between the two. Sounds like that's it for questions. All right. I guess that's all I've got. Thanks, guys.